Hello and welcome to the Physics Basket. Today we are going to cover class 9 topic 10 wherein we are going to discuss motion acceleration. So let's get started. Let's start with acceleration wherein we can derive the velocity time graph and then from there we can derive acceleration and different laws of motion. So let us look at some example wherein an object has covered basically at different point of time with different velocities. So at the time zero, it is zero means the velocity is zero, which means that starting with rest, and then at the time one, and the velocity is slightly increasing, and similarly on different time stamps, we are seeing the different velocities like 5, 10, 15, 20 at different span of time. So if we try to plot this between two different time spans, say initial time t1, when the initial velocity is u1, and the final velocity v at being time t2. So basically initial velocity is denoted by u in motion. So, and we have final velocity v. And if we observe at two different times t1 and t2, then this becomes the initial and final velocity. So if we try to find the acceleration between these two times, since we already know the velocity, so velocity is known, so in that case the acceleration will be the change in velocity divided by the change in time. So we know the change in velocity in this case between these two points. So till here this is basically v minus u, right? And the time, so time is between these two. This is the time. So basically it is t2 minus t1. So which is like, say it is the total time taken as t, right? So in that case we derive this, that acceleration is v minus u by t. T is the total time, delta t, nothing but t2 minus t1. So, or we derive this equation basically v equal to u plus at if we put the t on the other side, and then we finally transform and get this equation. So this is a case of basically a uniform acceleration, to be careful, and then at any point of time we get the acceleration is equal to 5 meter per second because it is uniform acceleration. So it's a 5 meter per second square as the acceleration. So let us look at the same diagram in a slightly different way. We need to basically derive the displacement. So we already know the velocity, we know the time. So when we plot the velocity time graph in a similar fashion that we did earlier, wherein at point t2 of the final time, the velocity is v2, and at point of time t1, which is the initial velocity, is u. And between these time frame, if you want to know the total displacement of the object, then basically we need to find out from the graph. So the the time difference here already we know, this is the time difference t2 minus t1. Here we are denoting it by delta t or t, and this point is v and this point is u. And the displacement basically during this course of time from between t2 to t1 is nothing but the shaded area, which is like, which falls between this particular um, area between distance time displacement time graph, which is nothing but e c a b and f, or ACEF. Basically ACEF is the ACE and F. This is the area. This is again, if we try to segregate into two parts, it is basically this triangle A, B and C, and then we have the other one as rectangle. So if we just try to find out these two areas and pieces, then we will, if we add it, then we get the total displacement. So coming to the triangle, this triangle is so the total, we know this part is u and this part is v. So in case of a triangle which is ABC, it will be half into AB into BC is the area of the triangle. So this particular portion is v minus u, right? So already we know C, B, and equal to B, BF equal to U. So now time is also known. So this is V minus U, as we already know. Now this part, which is AB. So the area of this triangle is half into AB into BC, which is nothing but half into V minus U into T. Now already from the previous equation of motion, we already know V equal to U plus AT or V minus U is equal to AT. So with this triangle ABC comes out to be 1 by 2 AT square. Half AT square is the area of the triangle ABC. Now rest left is to just find out the area of this triangle, which is very simple. It is basically the multiplication of the sides, in this case CE into BC. So BC is already known, that is T, and CE is nothing but the U, right? So just multiply it, it becomes UT. So this gives us the total area, which is nothing but UT plus half AT square, which is where we can derive the displacement of an object which is having an initial velocity of U and going with an acceleration A, and the total displacement of the object at the end of time t with this is equal to s equal to ut plus half at square. So coming back to the motion acceleration graph again, but here we are going to derive another equation of motion. So the same thing, it is traveling with a constant acceleration. In this case, the observation time is t1 and t2. The initial velocity is u and v, and we get the same triangle and the rectangle here. And again, going back to the same fundamentals, if we want to derive the displacement, it is nothing but the area under this particular frame, so which is nothing but the area ACEF. Okay, so ACEF is basically a trapezium, so we can simply derive it in a different way. In case of a trapezium, what is the formula of a trapezium's area, which is AF into CE, half of that, so half of AF into CE into the base, which is EF. So this is what gives us the area of the trapezium. So we just get a slightly different angle to it here, and CE is U, already we know CE is U, and then AF is V, this part is V, this shorter part is U, and so it is basically U plus V into half. And EF, what is EF? EF is T. EF is nothing but this part, so this is T. And then we again know V equal to U plus AT, nothing but V minus U equal to AT, right? So with that we get to know that T is equal to this particular T we are displacing, and then we get this formula. T is V minus U by A. So 1 by 2 into V plus U, this is V plus U, AF plus E, so into EF, right? So in this particular trapezium formula, we get 1 by 2 into V plus U into V minus U by A. This one we are replacing, which is nothing but the total area is nothing but the displacement. So displacement is V square minus U square, A plus B into A minus B formula. So V square minus U square by 2A. So, or V square equal to U square plus 2A. This is another equation of motion. That is how we have derived from velocity time graph. So let's have a look at displacement time graph when it's having constant acceleration. So the object is starting as usual with initial velocity u is equal to 0, and it is having a constant acceleration. And as we know already, we have derived this is equal to ut plus half at square. Since u is equal to 0, so replacing u0 here, we get s equal to half at square. So assuming that an object is moving with a constant acceleration of 2 meters per second square, the displacement values, just we are plotting a simple example. So at different point of time, we get something like this. So displacements at different point of time will be with 2 meters per second square. it becomes 0. At first second it is 1, second it is 4, third second it is 9, 16, 25, 36, and so on. So if you plot this in a displacement time graph, where a displacement is always on the y-axis, like distance also, and then similarly your time is always considered to be on the x-axis. So it comes something like this. So as we see, this plotted diagram is again, it's something like a parabola, and which is again, like the equation of a parabola is basically y is equal to a into x minus b whole square. It need to be a square actually here, and then plus c. So which is again equivalent to s equal to ut plus half a t square, which is already derived. So this is how it is in case of a displacement time graph. So this brings us to the end of the topic, and in the upcoming topic we will discuss the class 9 fundamentals on topic 11, wherein we are going to discuss the motion problems part 1. So till then, thank you for being here. Stay subscribed and stay tuned for upcoming topics. Thank you.